So here we go, 5.1. So this is section 5.1. And they're asking us to simplify by, it's kind of weird the way they say that. Just focus on the word simplify. So they want us to basically take that fraction and simplify it. Simplify that fraction. So 10x to the fifth over 2x squared. How does one simplify that fraction?
You subtract
The powers. Subtract the powers. And what do we do with the 2 and the 10? Yeah, just divide the numbers in the front, subtract the powers, huh? You all know that. 2 goes into 10 5 times, or 10 divided by 2 is 5. The 5 ends up on the top, not the bottom, because the bigger number's on the top, huh? If the 10 was down below, then the 2 goes into 10 5 times. The 5 would be on the bottom, huh? Mm-hmm. Right? Why is that? Well, because the 10 is really 2 times 5, and so the 10 is where the 5 is, right? So wherever the 10 is, that's where the 5 inside of him really is, the leftover 5. So that's where it ends up. All right, so wherever the bigger, probably an easier way to think of it, wherever the bigger number is. So the bigger number's on the top. Now, when it comes to the powers, where's the bigger power? Top. Now, they're going to subtract, aren't they? So that's going to be x to the third. So the answer is 5x to the third, isn't it? So out front numbers divide, powers subtract. Why do they subtract? Because x to the fifth, doesn't x to the fifth over x squared, doesn't it mean 5x's over 2x's? And then they cancel, and what do you got? Yeah. That's why the subtraction rule is true, because it's just a canceling of x's, isn't it? Does that make sense? All right. All right, so now let's go on to number 2. Number 2 here, so we have 5c minus 20 over 5. So let's do the same thing there. Just cancel those 5s. Is that okay to do? Claudia, you seem concerned. Several of you seem concerned. Got a factor at the top? No?
Well, no, because there's that minus. Yeah.
You can just divide 20 into 5. Save minus 4.
Can I do that?
Yeah.
Your hunch of no was correct. We can't do that. That's actually illegal. The math cops will come for you. It's a legal procedure. Now what? I don't think I've really told you the rule yet. I'm not really expecting you all to know it. I'm planning to teach it to you. It's because of that minus sign right there. That's the problem. Have I mentioned the Costco thing at all? I don't think I have I? No. I know the other class, yeah. Not in here. Okay. Yeah. It's the minuses and pluses are like shopping at Costco. That's the analogy I always make. Minuses and pluses glue things together. You know what I mean by shopping at Costco, Sam's Club, those big warehouse stores, If you go there to buy, they sell in bulk. You have to buy a lot. You can't, we have 5 kids. My wife shops at Costco. So you go there. If you grab one spaghetti sauce off the shelf at Costco, it's plastic to another one. They kind of connect them with 2 or 4. You can't take your scissors to Costco, cut the plastic, and say, thanks, I just want one. You can't. That's only you buy a bunch, you get a better deal. So that's what pluses and minuses are like in algebra. Pluses and minuses glue things together, make them a package deal. So when you see that 5c minus 20 over 5, this right here is glue, which means if you want to cancel anything on the top, you cancel the whole thing or nothing. You can't say, no, I just want the 5, please. No, that's like cutting the plastic at Costco. That makes sense? They're glued together. They're a package deal. Pluses and minuses. Now, if it was times, if that was 5c times 20, then you could totally do it. That'd be right. That'd be good. That'd be fine. It's the pluses or the minuses that are like the glue. They glue things together and make them a package deal. I don't want that just to seem like some weird rule that math made up, because it probably feels that way. Like, why? Is math like Costco? I mean, why are they doing that? Well, it's just like anything else in math. It's just simply true. Let me show you. What if you had 2 plus 4 over 2? Okay, and you thought you could cancel the 2's. How do you know that for sure that's just not true? Just looking at pure numbers. Like what is that thing really? Aside from any fancy math rules, 4 plus 2 is really, it's really 6 over 2, which is really what? 3. We know it's really 3, huh? And if I cancel the 2's, what have I made it into? 4, which is just not right. See how it's just not true? It's not just math's opinion or something. They're just following the truth. Now, I said to you that the problem is the plus sign or the minus, same thing. Meaning if it was times, it would be okay. Let's see that's the case. If that was times, now what is that really? All fancy rules aside, what is 2 times 4 really? 8 over 2, and what is that really? 4. So it's really 4. Is it okay to cancel the 2's now? See how it's right? So it's the pluses and the minuses that glue things that make you not allowed to. If you have times, that's like shopping in Save Mart. You can buy just one. That's totally fine. But pluses and minuses glue things together. It's a very important rule. Just this last hour in here with my pre-calculus students, or a couple steps ahead of y'all, I was doing the Costco story. And I do it with my calculus students. So way up the line, and it just continues to be an issue. Pluses and minuses. Everybody wants to cancel these kind of things. And you got to watch out. Pluses and minuses, they glue things together, make them a package deal. All right. So getting back to it. So, yeah, so we're not allowed to do this because of that minus making it a package deal. So that was a lot of talk about what we're not allowed to do. And Claudia, you started to say what is right. So if that's wrong, what is actually right then? If you can't cancel those, what do you do? GCF, you factor. Yeah, that's why we spent that whole chapter learning to factor, because that's what you have to do when you have pluses and minuses. Now, you guys are pros at factoring. How do you factor that numerator, that top up here? How do we factor that? Take out the GCF of 5, yeah. What does that leave inside? 2 minus 4. Is that good to there so far? Now, do you see how that 5 is just timesed now? It's just shopping at Save Mart. It's not glued to anything. So we get around the glue problem. That's why we're so obsessed with factoring, because it does that for us. It allows us to clean up these bigger, fancier expressions. As I told you, I was doing it in pre-calc. I do it in calc. All the way up the line, this kind of thing is very important for simplifying fancy math things. So the answer is just C minus 4, and we're done. Is that good? Want to try number 3 there? On number 3, can I just cancel these 3 x's?
No.
Because, again, the plus and minus glue. So instead we factor, huh?
Yep.
Factor the top, factor the bottom. And factoring makes them multiplied so we can cancel. All right, so how do we factor that? Numerator? 3. And then the denominator, very similar, huh? Now, can we cancel anything?
Just cancel the 3.
Those 3's, because they're times, huh? They're just, see how that, see what factoring does? It changes it from adding, subtracting to multiply, doesn't it? And multiply allows us to cancel because that's no longer glued. It's pluses and minuses that are glued. So then, and you don't even need the parentheses, by the way, anymore, because there's nothing to separate. The 3 is gone. You don't need to separate from the 3, so you can drop them. Now, can I cancel the x's?
No.
No, again, this is the glue problem, so we're done right there. We can't simplify any further. But the factoring made us able to cancel the 3's. That's why we're so into factoring. That's why we spent that whole chapter. Because it makes things multiplied and allows us, it's that one little snag of the plus and minuses. Thus, factoring is required. Good? So far, so good? So it's just, if you're good at factoring, these are just more factoring problems. That's what you are. Okay, so let's do number 5 up there. So on number 5, let me write it a little bigger for you. X squared over 8x plus 72. There we go. Okay. So yeah, so you see there's two factoring problems basically involved there, right? Got to factor this and this, huh? So factor those first, take out the GCF, and then cancel what you can. Use your calculator if you're rusty on some of those bigger times tables. We good to there on the factoring? Take out the 6, take out the 8. GCF now. Okay, so let's be careful with our canceling. Remember, anything that's plus or minus is a glue. So can I cancel the x plus 9s? Yeah, I'm buying the whole package, right? Costco will sell you the whole package. That's fine. I took the whole package there, right? The x plus 9. If it's all or nothing, I took it all. So it's fine. Totally fine. All right, now, is there anything else I can cancel? Yeah, there's a lot of other things. Yeah, the 6s. Yeah, you can go straight up and down or diagonal, either way. So 6 is a really good idea. Just cancel those. Anything else? Yeah, the x squared and the x to the 8th, right? Those are not plus or minus, so I can cancel those. And they're just going to subtract powers, aren't they? So this will end up being x to the 6th, and this is gone completely. They subtracted. Does that make sense? So what are we left with then? What's left on the top?
1.
Just a 1. Remember when the top vanishes a 1. What's on the bottom? An 8? X to the 6th. Yeah. Yeah, when the top of a fraction cancels, that always leaves a 1. I hope you don't see that as like some new rule or something. Think about like if you had 2 8s, what would that be? We all know that's 1/4, huh? 2 goes into 8 4 times. Because really what you're doing, we don't take the time to write it all out. But really you're dividing by 2 top and bottom. That's what's really, we just don't want to write that every time. But that's really what's happening when we cancel, so to speak. Does anybody have Miss Bazarinator for one of the earlier classes? She's always real careful and very faithful, very good math teacher, to say it's not really canceling, it's dividing out the unit. And she's right. She likes to emphasize that. So yeah, so that's good. That's why it's really 1 on the top, because we're really dividing by 2. Anyway, you know that, and so there's our answer. Questions on that one I can answer? All right, I want to try number 6. Same kind of thing. It's a bunch of factoring, really. It's a bunch of factoring. Factor the top and the bottom of that first fraction, right? So this piece right here, how does that one factor? Difference of squares, remember z plus 9, z minus 9? And then the denominator right here, take out a 7, z plus 4. And then the other part just stays the same. Z plus 4, z minus 9, we good to there. And now, what can we cancel? Yeah, z minus 9, z plus 4. I guess that's it, huh? So we're left with z plus 9 over 7. Yeah. So it's just a bunch of factoring, isn't it? questions on that? Good, okay. All right, I'm going to move on if you're good. Couple fractions like that. Multiply by the reciprocal, or some people say keep, change, flip. Whichever way you want to think about that. They both are true and good. Keep this one. Change to times there, and flip this one. Keep, change, flip, or multiply by the reciprocal. Same thing, exactly right. So you, bless you. Keep the first one the same. Change the one in the middle to times. And flip the one on the right. Keep, change, flip. So I change the dividing in the middle to multiply, and I flip the one on the right. Why is that correct to do? I think you know. Dividing is just upside down multiplying, isn't it? Do you know what I mean? Like if I said, hey, I've got 10 cookies, and I'm going to divide them among 2 people. Everybody knows the answer to that is 5. That's the same thing as if I took the 10 cookies and I multiplied by a half, huh? A half of 10 is also 5. You know that's the same thing. Dividing is just upside down multiplying, isn't it? So that's all we're doing there is we're just saying, hey, if they give me dividing, I'm just going to change it to multiplying where the right side is upside down. That's all we're doing. Okay, then it just becomes a multiply problem. And you know how to do this now. Does anything need to be factored here? There's no pluses or minuses really, are there? So we can just start canceling stuff right away. We don't have to. Everything is shopping at Save Mart here. There's no package deals, right? There's no pluses or minuses to worry about the packaging problem. We can just go for it right now. Start canceling. So use your calculator. Those are some big numbers. Can you use your calculator to reduce those? You can go straight up and down or diagonal up and down, either way. Cancel out what you can there. Give me a second. Cancel everything out that you can. So I'm going to go, well, there's a lot of ways to go. How'd y'all go? What'd you start with?
50 and 625.
Yeah, 50 doesn't go into 625, does it?
Reduces to 25 over 2.
Oh, did you divide them both by 25? Nice, that's a really good way to go. Yeah, if you divide both these guys, 20, you just got to guess at numbers, just start guessing around. Those are both divisible by 25. You just test it on your calculator, They're both divisible by, so divide by 25 leaves a 2. Divide by 25 leaves 25, doesn't it? Is that good so far? Just dividing top and bottom, both. But now, if you didn't know that 25 went in, you can just divide them both by 5. Yeah, let me show you. Maybe you think, I didn't know 25 went in there. Yeah, it's okay. You don't have to see the big whopping numbers. It's quicker if you do, but you don't have to. You can just divide them both by 5. And that would be 10, and that would be 125, and then just divide by 5 again. Like that, and divide by 5 there, and then you would have 25 there and 2 there. You'd get there eventually anyway. Just divide by 5 twice or divide by 25. Now I'm going to rewrite it. It's getting messy. So this is where I'm at so far. Everybody good to there? I just divided the 50 and the 625 both by 5. 5 goes to both of them, huh? And then I just did 5 again. It's quicker to just do 25 in one step. Anyway, get to here. What else can I cancel? Just be careful. Like how about the 2s? Oh yeah, and what goes into 10? And you can go straight up and down or diagonal. Either one's good. What about the 10 and the 25? Divide them both by 5. That leaves 2. That leaves 5. So now what do we have? We have x to the 4th times 2y squared over y to the 8th times 5x squared. We good to there? And now we can cancel letters, right? Did I mess up? Is that right? I think that's right. You can just put them all next to each other. It doesn't matter what order they're in. You put if it bugs you, put the numbers in the front. So now let's cancel out some letters. So y squared will go into to leave y to the 6th on the bottom. And x squared will cancel x to the 4th, leave x squared on the top. So 2x squared on the top, 5y to the 6th on the bottom. How we doing? Is that okay? Just easy to mess up somewhere, huh? With all that dividing and subtracting. Everybody see what I did? Hopefully I didn't mess up. Questions on that one? We'll try number 8. Number 8. Keep, change, flip again, with the divide. Dividing is upside down multiplying, right? So flip the 1 on the right, keep, change, flip. Simplify from there. Check with those around you, if you don't mind. See if you're getting the same answer on the last one or this one. Let me know. I'll wander around too, if I can help in any way. Check with whoever's at your table. Questions on the last one? Okay. Yeah, it's easy to just do one. What's that? Oh, I see. Instead of the x with the x. Yeah. It's easy just to do a little tiny thing wrong. A lot of mess up there. No, you can just leave them. Yeah. You did good. Perfect. And now that piece can factor. You break it down to a couple of parentheses. Yeah, very good. Yeah. The rest is just all, nothing more you can do. The rest is good. Yeah, so just be both those things on the top and just add them out. Oh, no, you just go to leave x minus 9 parentheses, x plus 1 parentheses. Can't do anything more. You got it, just leave the top there. Bottom. Oh, how about yeah, so it just stays x in the bottom. Good. This, all right. Let me go to a fresh screen here. And do this one with you. All right, so so we keep. And we change the sign in the middle, and we flip the 1 on the right. So x squared minus 81 over x times, and then flip the 1 on the right. Good to there? Keep, change, flip. And now, this guy is the one that needs to be factored, huh? We can factor him. So he becomes x plus 9, x minus 9, difference of squares. And now we cross cancel x plus 9 with x plus 9. Everything left is just left. You know, there's nothing more to do with it. Leave that x on the bottom. We can't cancel anything more, huh? You know, all good there. I don't know if you can read my scribbles over here. It got kind of messy. Like that. And that's it. Why can't I cancel like this x into one of these guys? Yeah, these are glued packages, right? Plus and minus. So x minus 9 says if you want to cancel me, you cancel the whole thing or nothing. You can't just take the x part, huh? It's glued to the minus 9. They're a glued package. So package deal. Like that. So that's just our answer right there. Questions I can answer? We good? All right. There we go. That's a mess. Wait, did I do that right? Oh, they put parentheses on this too, didn't they? There we go. All right. What a mess. So, yeah. What should we do with that? Well, we've got to keep, change, flip, don't we? So let's start with that first. Let me do this one with you. This one's pretty messy. So keep, change, flip. So this is keep this the same. Change this sign here. And this guy, flip. Which is weird to say because he's not a fraction. Isn't that a little weird to say? Like, what do we mean flip something that's not a fraction? Yeah, right now it's over an invisible 1. So when you flip it, the 1 goes to the top, huh? We good with that? So let's do that. So keep it. So p squared minus 49t squared times, change to times, right? And then flip. And then the other part. All right, so now we're to here. Now what do we do? Yeah.
After we change and flip it, is it still in the parentheses or just?
Yeah, good question. Those outer parentheses, like right here, they're not really important. You could drop them. They're not doing anything. You can keep them on or off. It doesn't matter. Either way. Nothing important there. Like that. And even the inner ones. Yeah, those inner ones I removed as well. Yeah, the parentheses don't really matter in this one, so I'm just getting rid of them. So either way, you leave them on, that's okay too. It doesn't matter. They're not making an important difference. Okay, so now what is there anything that needs to be factored? This piece right here, huh? So factor that and then just start canceling anything you can, top and bottom. Can you factor that piece and then just cancel like crazy? Give you a second. Oh, this part up here, factor that. P, how do we factor that thing? Yeah, it's a difference of squares again. Plus 7t, whoops. And then p minus 7t, huh? Good there. Is that good? And then we just cancel. Anything top to bottom. You can go straight up and down or diagonal up and down. It doesn't matter. So p plus 7t, p plus 7t. P minus 7t, p minus 7t, huh? What's left? 7t over p plus 7t. Can I cancel those 7t's? Can I go like this and like that? Why not? Because the bottom says we're glued together. We're a package deal, which means you want to buy any of us, you buy the whole package or you buy nothing. Yeah. So we're going to buy nothing there. So we leave it just like that. And that's our final answer. Is this making sense, this section? Questions I can